Hey guys, I'm the math professor, Kyle Martin. In this video, we're going to talk about 5 things that are going to be on our quiz in our reasoning and proof unit. Okay, before we do that though, real quick reminder to subscribe to this channel. If this video helped you, if one in the past has helped you, please subscribe. And when you do, just write a little comment in the comment section saying, I subscribed, and I'll be sure to respond to your comment. All right, there's timestamps in the video player down below. Go ahead and click on whichever topic you need, whether it's patterns, counterexamples, conditional statements, laws of logic, or proofs. All right, here we go. All right, first up is patterns, okay? When we have patterns, it's either gonna be going up or it's going down, all right? There's a couple of exceptions to that, but for what you're gonna see on the quiz, we have either down or up like you see in this one. So first off, we need to decide how is this going down. Okay, it looks like from 128 to 64 to 32 to 16, this is going down pretty drastically, all right? It's probably not just like, you know, minusing 1, minus 2, minus 3. It's nothing like that. This is actually being divided. 128 divided by 2 is 64. 64 divided by 2 is 32, and so on. So we need to divide our next term by 2 in order to get to replace our question mark. 16 divided by 2, of course, is 8. All right, so hopefully you can see the pattern that way. If you're going down, you're either dividing or you're subtracting. Similarly, in question B here, we're going up. When you go up, you're either going to be multiplying or adding. All right, again, there's a couple of exceptions to that, but for the most part, that's what you're going to see on your quiz. This one goes from 4 to 9 to 16 to 25. Let me really quick see. This was dividing. Is there anything I can multiply? 4 times... No, right? 4 times 2 would be 8, and that's as close as we get. 4 times 3 is already past it. So let me try addition now. 4 plus what is 9? Well, that's plus 5. 9 plus what is 16? That'd be plus 7. 16 plus what is 25? And that would be 9. All right, so hopefully you can kind of see the pattern here. 5 plus 7 plus 9. We're going up by 2s. So the next one I need to add 2 plus 11 is, or 2 plus 11. 2 plus 9 is 11. So if we add 11 to now 25, we of course are going to get 36. All right, number 2, counterexamples. Counterexamples, it's going to give you some sort of sentence or maybe some math that you have to do, and you just have to come up with a way where you can prove that wrong. All right, when you can prove it wrong just once, that's a counterexample to what the law or the rule is that they're trying to tell you. So in this case, it says the sum of 3 consecutive numbers is always even. So we have to remember a couple things here. First off, sum means add. 3 consecutive numbers, those are like 1, 2, 3, 8, 9, 10. Okay, just numbers that are in a row, integers. And then always, whenever they use the word like always or never, you want to probably disprove that. So it might happen sometimes, but you're going to try to disprove the fact this is saying always. All right, so let's just try. Let's put a couple up there. Like I said, I had a 1, 2, 3, 8, 9, 10. Let's just try those 2 and see if we can prove it wrong. So we're looking to see if this is going to end up even. So when I add 1 plus 2 plus 3, that's 3. 3 plus 3 is 6. Yes, that one is even. What about my other one? 8 plus 9 plus 10. 8 plus 9 is 17. 17 plus 10 is 27. That's odd, okay? 27. So go ahead and just try a few of what it's saying to see if you can come up with an example where you prove that statement wrong. Okay, third thing that's going to be on your quiz are conditional statements. Conditional statements usually give you a sentence to start with, and then you have to come up with either 4 or 5 of these different ones. We have our conditional, our converse, inverse, contrapositive, and our biconditional. All right, so I'm just going to give a real simple sentence here. It says, when I'm hot, I wear shorts. Okay, if it's in a conditional form, we have to write this as an if-then statement. All right, so how could I change this to say something if-then? Well, I'd probably start with if, let's see here, if I'm hot, then I wear shorts. All right, I'll write that out. I wrote that out there for you, and before we do our next few, just to remember, our part that comes after the if but before the then is called our hypothesis. All right, I'll just abbreviate that for you. And then the part that comes after the then until the end is called the conclusion. Okay, so those are going to be important with our next couple because our converse, inverse, contrapositive, and biconditional kind of switch some things around, make some things negative. I'll show you what I mean by that here in a second. All right, so our converse is actually going to take our hypothesis put it after the then, and take the conclusion and put it after the if. So it's going to switch those two parts around. So this is what it would look like. Okay, if I wear shorts, then I am hot. So again, we took the part I am hot and put it at the end, the part where I wear shorts and put that at the beginning. Again, our if and our then stayed in the same spots. Okay, the next one's called the inverse. The inverse keeps it in its original order, but it makes them negative. All right, negative, or you could say it's the negation of that. So instead of if I'm hot, we're going to say if I'm not hot. Okay, so sometimes you use words like aren't or weren't or don't. So just things that make those words negative. In this case, we're just going to add the word not. All right, let's write it out. Okay, so you can see I wrote this, if I'm not hot, then I won't wear shorts. You make both parts, the hypothesis and the conclusion, negative by saying I'm not hot and I won't wear shorts. Those are both negative words. Okay, the next one's called the contrapositive. This is a mix of our converse and our inverse. We're going to switch around the hypothesis and the conclusion, and we're still going to make them both negative. Let's try it. Okay, so you can see that I switched it around. I said the conclusion is now in the front, right, if I wear shorts, but then I also made it negative. If I don't wear shorts, right, and then I took the hypothesis and put it at the end and also made it negative. Then I'm not hot, okay? So, let me fix that really quick. There we go. All right, so then there's one more, and this last one is a little bit special, and it's the biconditional. This one we're going to get rid of our if and our then, and we're only going to use the hypothesis and the conclusion, and we're going to put the phrase if and only if in between those. So we're going to say, I'm hot if and only if I wear shorts. Notice I didn't say anything about if or then, so it'll look like this. Okay? So hopefully that helps you out with the conditional statements. We have our 5 over here. Let's try the next one. All right, fourth thing that's going to be on our quiz is the law of logic, specifically the law of syllogism and the law of detachment. All right, so syllogism is when they give you a string of sentences. It can be as little as 2 or as many as all of them, and it's going to have parts that cross out. Okay, so there's going to be duplicates after our then and in front of our if, or I guess after our if, that are going to cross out. So here it says, if I dog sit, then I'll go to the park. If I go to the park, then I'll get dirty. If I get dirty, then I'll shower. So you'll see here that these parts kind of repeat, and you can cross those out. So let's see, if I dog sit, then I'll go to the park. If I go to the park, so here we have, I'll go to the park. If I go to the park, those will cancel. Then it says, then I'll get dirty. It says, if I get dirty, then I'll shower. So the part about getting dirty is going to cancel. And you're left with, if I dog sit, then I'll shower. Okay, one thing, I wrote that up here real quick for you, but it's still in that if-then form. It's still a conditional statement. If I dog sit, then I'll shower. All right, that's the conclusion you can make from this line of syllogism. Okay, the next one is a law of detachment. This is going to give you an if-then statement, and then it's going to give you something that happened that regards that if-then statement. Okay, sometimes you can come up with a conclusion from that if-then, and sometimes they don't give you the right information, so it won't work. Okay, let's check out this one. It says, if James studies for the math quiz, then he'll pass. All right, so we have the if-then, if he studies, then he'll pass. And then down here it says, James studied for math tonight. So because this specifically applies to our hypothesis of him studying for the math quiz, our conclusion is going to be the conclusion of that if-then statement. He will pass. So we can say, for our conclusion of this one, James will pass the math quiz. All right, James will pass the math quiz because that's the conclusion of our if-then. Since he's going to study, he's going to pass. Let's try number 5. All right, number 5 is proofs. Last thing that's going to be on our quiz is proofs. And in this one, what we're going to do is have a 2-column proof, where one side is our equations, where we're just going to solve this like we would in Algebra 1 class. And then on the other side is our reasons. Remember, we have the addition, subtraction, multiplication, division, properties of equality, where we move stuff over and across our equal sign. We have our symmetric, reflexive, and transitive properties, which they don't happen too much in algebraic proofs. We'll get into that more when it comes to like the shapes in geometry. And then there's some other ones like distributing, combining like terms, all right, and a few like that you have to remember that could all be possible reasons for a proof. Let's try this one. It says 4 times the quantity x plus 6 minus 5 equals 2x minus 1. All right, a lot going on there. But what we need to do first is probably distribute this 4 in, okay? And actually, I forgot one thing. When they give you the problem, our number one reason is always called the given, right? Just like we talked about in class. This is like a free answer. If you don't know how to do the rest of this, at least put the word given on line 1 of the reason. All right, given. Now, like I said, we need to distribute this 4 in. And when I do that, that's going to give me the next line that's going to be 4x plus 24. Then just bring down the rest. Minus 5 equals 2x minus 1. Okay, the way that we got that is by distributing. So the reason I'm going to say is the distributive property. Okay, next thing we need to do in our equation, it says 4x plus 24 minus 5 equals 2x. I have some like terms over here that I can combine. 24 minus 5 is 19. So I'm going to combine those and say 4x plus 19 equals 2x minus 1. And again, I did that by combining like terms. So let's write that out as our reason. Okay, so once we combine our like terms, then looks like we can maybe move this 2x over by subtracting it. So minus 2x minus 2x. Real quick note before I write that line down, the work that we do in between some of these lines isn't going to count, all right? So we need to just move our 2x over, and then this next line is what we're going to really use for this number 4 here, right? 4x minus 2x is 2x plus 19 equals, that cancels, so now just equals negative 1. Again, we did that, we got this line by subtracting. So we're going to say it's the subtraction, and I put POE for property of equality. Subtraction property of equality. Okay, and then let's see, what do we have to do next? In fact, I might need one more step, but it says 2x plus 19 equals negative 1. If we subtract 19 on both sides, now we have, for our next line, 2x equals negative 20. Okay, and again, I got that by subtracting again. Subtraction property of equality one more time. Okay, the last step, if I write a couple more steps in here, 6 and 6, the last step is going to be division. I have to divide both sides by 2 to get x equals negative 10. All right, and I did that by the division property of equality. Again, division POE, division property of equality. All right, and that should round out everything that's going to be on our quiz. Hey guys, hope you found this video helpful about what's going to be on our quiz coming up here in our reasoning and proof unit. If you did find this helpful, remember, leave a comment down below saying that you subscribed and hit that subscribe button. I'll be sure to respond to all your comments. Thank you.